Hi, everyone. I'm Wissal, and I'm a computer science student at the university. First of all, I'd like to thank you all for being here today for my thesis presentation. And special, very big thanks to my supervisor, Ian Thurer, who assisted me through my whole projects. So let's get started. Cybersecurity is an essential component of the digital world. With the increasing reliance on technology, organizations across all sectors face a growing risk of cyber attacks. One very big incident that happened a couple of years ago, which is the Capital One data breach in 2019. In this breach, a hacker exploited a misconfigured web application firewall, getting unauthorized access to personal information of over 100 million customers. Yes, you heard that right, 100 million customers. And this leads us to our motivation. Financial institutions face diverse threats, including malware, phishing, and ransomware. These attacks target sensitive financial information, leading to severe consequences. These consequences underscore the critical need for cybersecurity strategies to protect financial organizations from evolving threats. Well, now what is our main objective through all of this? Well, our main objective is understanding cybersecurity threats by developing an adaptive network model that stimulates a cyber attack. And by doing so, we can gain insight into how such attacks occur and identify strategies to prevent them, ultimately enhancing our ability to safeguard sensitive information and maintain security. Now, let's move on to the approach. Well, our approach is an adaptive network model that integrates elements from the cyber kill chain. Well, you're probably wondering what is the cyber kill chain, right? So let me tell you what is that. The cyber kill chain is a framework that outlines the stages of a cyber attack from the initial start to the final objective. By incorporating this framework, our model aims to simulate the behavior of both parties, the attacker and the defenders, providing a very deep understanding of how cyber attacks unfold and how they can be mitigated and prevented. And now let's move on to our network picture. If you look at this slide, this is our base network model, which showcases how a cyber attack occurs from two different perspectives, from the organization perspective and also from the attacker perspective. The organization perspective is for X1, so from initial state, goes vulnerability, delivery, exploitation. But then if you look at X2, X4, X5, and X6, those are stages from the attacker perspective. As in, the attacker start by reconnaissance stage, when trying to understand how the systems work in organization, to later on be able to infiltrate them. And then if you look at X6, it has two outcomes, X7 and X8, which are the success or fail of the attacks, which will focus mainly today on this presentation. And as I previously mentioned, our model also includes very important stages from the cyber kill chain that I previously defined. For instance, reconnaissance, organization, delivery, exploitation, persistence, and finally, command and control. Well, now let's discuss our methods. Well, in order to run our simulation, we'll use the adaptive network-oriented modeling environment developed by Jan Thurer. And the implementation is going to be, we're going to use for implementation some role matrices in order to define state influences, connection weights, processing speeds, combination function, and function parameters. Well, now let's look at the simulation results for our non-adaptive graph. As we can see here, there are many repeated attacks. This graph shows like many repeated attacks over time, and each attack is a period of 40 seconds. So let's shift our focus to one attack only, so we can really see what's happening in there. So we have two curves, right? We have the red curve and the green curve. The red one shows the success of an attack, and the green one shows the fail of the attack. In this case of our non-adaptive model, the red curve goes above the green curve, which basically translates to the successful attack, which means that the attacker did indeed infiltrate the system of the organization. And of course, this is not really what always happens in real life, right? Because in real life, we have a lot of external factors that comes into the whole scenario. So this is exactly why we introduced some adaptive states in order to reflect dynamic behaviors and interaction between the states. Well, if we see here, the bottom is our base scenario that we previously mentioned, and the top one in red represents the adaptive states that were added to reflect dynamic behaviors between the states. And now and first of all, before I start explaining what's happening in the simulation, I'd like to mention that we're going to look at our model story from two different perspectives. The first perspective would be from the attacker perspective, when the attacker learns better than the organization. And the second one is when the organization learns better than the attacker. So yeah, this is the first case where we have the attacker that learns better than the organization. If you look at the red curve, which is again symbolizes success of the attack, and the green curve is fail, and the blue one is the learning process of the attacker. We can see that like in the first 150 seconds, we see like alternation between the red and the green curves. This basically means that both parties are learning at the same time, the attacker and the organization. But if we look at learning later on time, we can see that the attacker learns more, which means that the curve for the success goes over the curve for the fail and surpasses that. And if you see over time, there are many successful attacks. And that again is because the attacker was learning better in the scenario. And now and from all that scenario, the outcome would be the data stolen, which is very unfortunate. So yeah, the orange line shows the outcome of the data stolen. And now we will look at our second case, which is when the organization learns better than the attacker. In this case, if we look at the orange curve, the orange curve is the learning process of the is the learning curve for the organization. And again, in order to understand this very well, we will shift our focus just to the two main important parts of the graph, which are the success and the fail. So the two curves, green and red. And we're going to divide this into three different phases in order to understand it properly. And we're going to explain them according to the learning. So the first phase is this one. We can see that the red line, which is the success of the attack, is still over the green one, which basically means that like the attacker is still learning. They are both learning, but the attacker still learns more and better than the organization. But then again, over time, we can see that then the next one is the green one that is over the red one, which means which translates to that the organization now start learning better and better over time. But if we see after that, that learning was not enough, and the attacker was also learning even more. So it also went above the green line. So and this explains the alternation between the two. But then if we look further during the time, we can see that the learning of the organization went very high, and then the curve for the fail of the attacks stayed on top for over time. And yeah, so basically what we can say from this is that the learning effect is better over time. And if you want to say it in plain English, that practice makes perfect with time. And of course, there are many other factors that could influence our scenario and our model. I did study them more in depth in a what-if analysis, but due to time constraints, I included that in my paper, but not really in this presentation today. So that is all for today, and thank you for your attention.